So now let's work through this next problem. An environmental group takes 30 samples from a river. They get an average pollution level of 4.5 cc's per liter of a certain pollutant, and this takes sigma to be 1.2. They want to claim that the average pollution level of the river exceeds the EPA regulation of 4 cc's per liter. Oops. What can you conclude about the claim, and at what confidence? So what's the first thing that we do? Right. We have to, yes, write it down. Write what down? Yeah. So what kind of question is this? This is a hypothesis test question. So the first thing you do is you write down your hypotheses. So in this, hypothesis is the same as claim. In this problem, what's the claim? Right. There's the claim. Now how can we write that down in notation? Okay. Something is greater than 4. What's greater than 4? Yes, the average pollution level. Now how do we write that down in notation? Exactly. Mu is greater than 4. Now is this HO or H1? Exactly. This has to be H1, and how do we write down H0? There you go. Equals. Okay. So these are your claims. Now we're ready to go to work the same way that we've been doing all along. So what's the first thing that we do? Okay. Before we draw the picture, what do we have to do? Sorry? That's the last thing we do. Right. We need to do our initial assessment, which includes finding out whether or not it's normal. Now remember, I always say that there are 3 things that we should do first, of which finding out if it's normal is the 3rd thing. What are the other 2? Right. So, the mean. Now what's the notation for the mean? It's not mu. Mu for x bar, exactly. Mu for x bar is what? Nope. Mu for x bar is the same as mu for x bar is the same as mu. We talked about that for quite a while. And what is mu in this problem? Okay. No, mu is 4. That's a good question. What is 4.5? Let's write this down. Is 4.5 the average for the population? No. What is it? 4.5 is the average from the sample. So in notation, what is that called? What is the notation for the average from the sample? Mu is what? The mean for what? Mu is the mean for the population. The mean for the sample is x bar. Right about now you should start getting this straight. I know, but right about now from working problems you should be getting this straight. Yes, but we've been going through it for about 2-3 weeks now. Okay. Okay, well that's why we're working on it. Alright, so we've got down mu x bar. What else do we need? Right, and the notation, what's that called? Sigma for x bar. And what is sigma for x bar? Right. So in numbers, what is this going to be? 1.2 divided by, yes, n is 30. So let's work out what that is. Oops. And let's take this to 4 places. Okay. That's 0.2191. And what's the next thing we need to figure out? Exactly. So, is it normal? What tells us whether or not it's normal? Right. Right. So is the sample size at least 30? What's the sample size? 30. Okay. So now what can we do? Now we can draw the picture. Alright, now what do we label on the picture? What gets labeled on the picture? 0 in the middle for what? Z-scores. And what else? Okay, we've got x bar values, and what goes in the middle for x bar? 4. And what else should I mark down? 4.5. And now what? Because what do we need to do now? Well, what do we need to do on the picture? Shade where? Shade to the right of what? Of 4.5. So again, I know the expression is mu is greater than 4, so you want to start shading in 4. But think about the way that we're going to draw a conclusion. We're going to say, assuming that mu is 4, what's the likelihood of getting an x bar that is 4.5? Then we're going to say or greater. So that's why we shade to the right of 4.5. So now what? Z-score. So how do we find the z-score? 4.5 minus 4 divided by our standard deviation, which is 0.2191. And let's figure out what that is. .2821. So there's the z-score. We could fill that in. And now what? Find the areas. So 0.9888. So what is 0.9888? Yeah, it's the area to the left. And then let's also fill in the area to the right, which is going to be 0.0112. So now we've done all the calculations. So now we're ready to answer the question, which is what can you conclude about the claim? So what's our conclusion? We're 0.9888 confident that what? So we're 0.988 confident that mu is bigger than 4. Yeah, Tierno. Okay. Other questions about what happened in this problem so far? Right. So the way to think about it is the following way. To get what's the likelihood? So if mu is 4, what's the likelihood or probability that x bar is 4.5 or greater? Exactly. So that's what would be true if mu was 4. So flip that around. So how likely is it that mu is greater than 4? If it's 0.0112 likely that mu equals 4, then how likely is it that mu is greater than 4? The opposite, 0.9888.